Hi, everybody. I'm Denis Gagne from Trisatech. I'm the lead of the ambassador program at the BPM Plus Health uh, community. And what we wanted to do here with the help of John Svirbely is show a quick prototype that we developed in the last week and a half, 2 weeks, really, about how to actually automate the material that was just shown in a more global context. So this is work that we've done in collaboration with the IOI, more particularly on the IOL. So the goal of this quick showcase here is to showcase three things. One is the usage of the fire consent resource. More specifically, we're going to use a use case that's not the one that was developed for that resource by the PASIO group, but it is, we're using that same resource. We're also going to showcase how we can use these visual process and decision model, the like of what you just seen in the intro, and we're also going to show how we can integrate this in a realistic healthcare ecosystem, in particular the IOL from IOI. And so for the global setup, this is done completely in the clouds. So all of what we're going to do here is completely cloud-based. So from the modeling of the model, as you just seen, to creating the service, and then using the CDS hook to go connect into an EHR mockup that it's itself connected to the IOL. And one of the main points that was presented earlier, and one of the main points we want to push here, is the fact that with this approach, you have a single artifact, which is the model. And that visual model that we just see becomes the guideline specification, it becomes the guideline logic, it becomes the guideline documentation, and becomes the guideline code. So one of the main benefits is that you have a single knowledge artifact to manage the life cycle. So you don't have to have 4 or 5 different artifacts that you have to manage 4 or 5 different life cycle. A single artifact does the complete job for you. And I'm going to pass it to John to talk about the demo scenario we're going to do.
Hi, thanks, Denis. Yeah, today the example we're going to give relates to preoperative care for total knee arthroplasty. And one of the goals for the demonstration is to show that consent exists in context with the other steps that are present. There's both practical and temporal reasons for that. For example, in the case of elective surgery, you can't do consent until you know that you can do the surgery, which usually requires several steps before. You have to establish a diagnosis, then you have to get pre-authorization. Only then would you do the consent. Once you do consent, downstream functions are also affected, because if the person does not give consent, prehabilitation or prep for surgery are not relevant. If they are, then they do become. So it is something which is not by itself, it's part of the whole process. And so to illustrate that, we'll have models in BPMN, DMN, and CMN. So this is the first step in the process that will be illustrated in the example. And this is the process for pre-authorization. And you go through several decisions. One is at the left, there's contraindications for TKA. If there's a contraindication, then the person does not have the surgery. If there is, then you have to determine, does the person meet the criteria for having the procedure based upon severity. If they don't, then they're rejected. And you might do an alternative care. If they do, then you go to a trial of alternative or conservative therapy. If that works, then you do not need to proceed. If it doesn't work, then you're a candidate for going to the next stage in the process of pre-authorization and approval. Further down the line, we've next come to the decision of consent, where, okay, a person's been approved. You check for advanced directives, since that might impact some of the decisions. Then you go through the process of querying the decision maker, and we've discussed that just previously, to decide if they're available and if they are willing to give consent. The person who's been identified then reviews the consent, signs it, and the consent is then entered into the medical record where it is available for surgery. If the person again rejects it or is uncertain, then you would loop back for additional steps. So that takes it back to you, Denis.
Okay, thank you, John. So let me quickly show you. So for example, we have these model. Now these are the diagram that presents the business logic or the logic here that needs to take place. And so what we can do is we can publish these as services. And once you publish it as a service, then you have a service here that will do the TKA consent form. And then I can go and take this service and invoke that service from any kind of environment, an application, a EHR, EMR. So for the showcase purpose here, we have a sandbox for demoing. So imagine this is a mock-up of some kind of a EHR or EMR system that you have. And so we will take the endpoint of that service, and that service does both the chain of the total knee arthroplasty work of deciding whether we should go ahead with the procedure, and if we go ahead with the procedure, then we actually get consent. So if I add this service to my mock-up EHR, EMR here, then automatically, and for those of you that are more astute on the technology side, this is using CDS hook. So I added a CDS hook endpoint for that service, and now you can see that the TKA consent service ran, and in that particular patient here for Michelle Olin, she didn't have any contraindication for the surgery. She didn't meet the criteria, but she had not failed yet the conservative therapy. So the result is to resubmit for an adequate trial after the conservative therapy. So that was one of the paths that John demonstrated. And I can switch from patient to patient, and then this service will run. For example, George here has contraindication for the surgery, so we reject pending the problem resolution. And if I move to Rose here, in the case of Rose, everything lined up and she's approved for the total knee arthroplasty. And then we can move into an aspect. So this portion was completely what we call unattended or straight through processing, was running automatically in the back. And now we step into a step where we need to involve human in the loop. And so then the next point is to query the decision maker. And this is based completely on the consent resource in FHIR from the Passio group. So who is the patient ready to consent? Yes. Who's the consent signatory? We'll say the patient in this case. Then we can move forward. Then we can review and sign the consent. So at this point, we would pull a consent document and get it signed by the patient. And then we can pull up that file, add it in here, run it, and then this is completed. So if we go back to our environment now and I go look into the details of Rose, I can see that now a new FHIR resource has been added, which is the consent, and the consent is available there, and I can click here and access this consent that was added into the FHIR server in this case. So basically what you've seen here, it goes fast because automation is rapid, but we went through all these steps for each of the patient as we were clicking of figuring out whether they're correct for the approved for the surgery, and if they are approved for surgery, then we would go through these series of steps to the point of getting the consent, uploading the consent into the environment. So this is all done and written into the various elements of the network there, the ecosystem of IOL, writing to the different, so we can write the consent back to the provider system, we can write it back to the payer system, we can write it back to other kind of registry and national registry or local registry. And while this was all running, as Ben mentioned earlier, we're able to trace all these steps. So every single step that was done, we have all the information that is traced. So with that information being traced, we can actually use that data as feedback on how we're performing against these methods or guidelines that have been defined. Naturally, these process diagram and these different decisions are built based on published best practice and evidence type of material to give us a proper guideline that's accepted globally.
So Denis?
Yes, sir.
This is Ken. If I could just interject one point, forgive me. Just to connect dots, and maybe you could go back to the screen where you were showing the kind of interaction. But for those that are perhaps one step removed from the technologies here, just a couple of things that were in play. So one is you have a workflow that has been expressed using a set of standards. You have a consent resource that has been represented using a different set of standards. You have an API or an interface between a simulated electronic health record and decision support type system that is based upon a standard. And then it showed the interaction of these business processes with different IT systems based on open representations of knowledge to perform a business task. So I'm saying the same thing Denis said in different words, but I think it illustrates kind of the confluence of what we're facing in this advanced care planning environment, where you've got different interacting business processes and policies interacting with a whole host of different IT systems, and the need to represent different data and different processes in ways that can be shared and shareable. So I think that's why this demonstration was really insightful, but I think I fear those that may not have been as close to it might have missed some of the dots. So hopefully I connected a few. Over.
Thank you. And going back to an earlier point that we made about the fact that this single artifact, this model, is not only a representation of the logic, but it is also the code for execution, and it is the documentation. So if I generate from this model here, I'm getting also the actual guideline documentation that is extracted directly from that model. So all that information is right within the model in the different pieces here. So you have all the details that are added into the different elements. Sorry, I'm clicking away, making you dizzy probably. And so you have all the details, the definition of all the steps, and the documentation of it. So a single artifact is really all you need to manage this single knowledge artifact, which reduces a lot of problems with versioning as things, guidelines get improved, as we get more evidence from the automation, getting all this evidence about maybe we're not that efficient or we don't use a few steps that we thought we would be using, then we can go back, redesign, and we have a single artifact to update, and everything now operates in the new way. So hopefully that gives you a glimpse of what's possible using the BPM Plus Health series of standards and connecting this to what's going on in the PASSU project at FHIR, HL7, and also connecting this to ecosystem environment, synthetic environment like the one that IOL is providing graciously from our friends at IOI. And that's it for me. I'll pass it to the next speaker. Thank you.